Hello and welcome back to another video. This one was actually sent in on Twitter. Actually, we can show that real quick. This was sent in by Sardorbek. Sorry if I pronounced that incorrectly. This is a follow-up to a previous video which I posted about blank except in Python. And while I don't quite have enough time to explain all of exceptions in one video today, I think we'll answer his question. And his question is, in the video, I used raise keyboard interrupt pren, and I could have also done raise keyboard interrupt without parentheses, and we'll actually show why the latter one is a little bit better. You can also read this Stack Overflow article, which is going to say essentially the same thing. But we'll look into that and show why it's slightly different, even though it's, according to Python code, exactly the same. And I'll also show you another bug that I fixed almost 5 years ago now that's closely related to this problem and a place where it could actually cause a difference in behavior. So let's jump into that. So I just want to first show that both of the code samples do exactly the same thing. So we're going to make a little example here. And if we have F, which does raise keyboard interrupt, and this is what I had in the video with parentheses. But if we do the same thing without the parentheses, and I don't know, make a little main function here. Name equals main, exit main. And we call this function as e print e. So let's first call F, which is the one I had at the video. So you can see I've just set up a small little demo thing that we can run. This one raises keyboard interrupt with parentheses, and this one raises it without. If we run this, well, we print E, but since the exception has no arguments, the string of it also has no arguments. So when you do print, it implicitly calls stir. And so it's printing the empty string here, which is not super interesting. But we can do something like type e dot name. Yeah, something like this. So this will print the class name and then the actual object. And we'll see that we get keyboard interrupt, and there's one space here, which is this space here, and then the empty string afterwards. So if we do that with F, we get that, and if we do it with G, actually get the same thing. Same white space here, and if we look at this object here in a debugger, and we'll switch from Python 3 to 3.7, which has the breakpoint built in, you'll see that if we print E, it's keyboard interrupt with pren, even though we didn't call it with parentheses up here. And so the answer is both of these syntaxes work, but you should prefer the one that I didn't do in the previous video. And the reason for this is slightly, ever so slightly faster. And we can actually explain why it's slightly faster. If we run this in interactive mode, right, we need to not have, well, we can still have the main function, that's fine. System exit none. Oh, right, because it ran exit down here. Oh, but we still have an interactive thing, so everything is fine. But we're actually going to use the same tooling that we used. Which video is this? I don't remember, but we've used the disassembler before, but we'll actually be able to use the disassembler again to explain the differences here. And if we call dis.dis on F, so this is the one. Oh, actually, yeah, we'll be able to see it here. Okay, so if we disassemble F and we disassemble G. And again, the only difference between the two functions are those parentheses there. You can see that we have one slight difference, and that is that G runs one fewer opcode. So there's this extra call function opcode that exists inside of F. And that's the main difference in the execution time here. We can also show that one of them is faster than the other. How would I do that? We can, well, let's let's talk about this first, and then I'll show the time it to show that one is actually faster than the other. This is going to eagerly call this class and instantiate an object before it raises the value here. So call function 0 will be, pop one element off the stack, which will be this keyboard interrupt class, and then call it, and then push it onto the stack. And then the rest of this is still the same. It's still raise var args1, which is pop one element and then raise it, and then your implicit return none at the end of the function. Oh, it must have been the no return type annotations video. That's what it was. But yeah, this call function incurs a little bit of overhead that can sometimes be avoided. And what the Python documentation somewhere states is that if you raise with just a type name, it will be instantiated with 0 arguments as needed. And that as needed is the main difference in execution here. If, for instance, like you have an accept block that doesn't need to inspect this exception object, but just needs to know about the type, it might not instantiate in that case. Or if, it's handled in C, or like you just have a blank accept block that ignores it, or any other places like that, it will avoid instantiating this object. Now, granted, the performance here really shouldn't matter. Like if you have performance critical raise statements in your code, you might want to refactor to not be using, exceptions as control flow. But it doesn't hurt to be slightly more correct, I guess. Is the bottom line there. All right, so let's show the difference here. Except keyboard interrupt pass, and we'll do the same thing for F, and this will allow us to, except this one we want, or sorry, G. This one we want to not call it. So if we interactively run this again, and yeah, ignore the system exit, that's just because I have exit over here. But if we import timeIt and do timeIt.timeIt, I'm bad with the timeIt module. I think it's just F, yeah, and then G. That's the opposite of what I expected. I guess we need to run it a few times. Oh man, these numbers are so variable. Okay, that's kind of what I expect. I would probably need to run it a lot more times and then show like some variance here, but I don't know, this kind of, at least when I ran it a few times, like this one was always under 480 milliseconds, and this one was always above 480 milliseconds if we ignore this outlier here. Anyway, it's gonna be slightly faster. It's not a huge difference though. And I'll actually show you a case where this caused a bug in some C code that I actually wrote. Let me go to that really quickly. In C, this difference can be a lot more pronounced, and a lot of the C code in Python will not necessarily instantiate the exception instance and the traceback, and leaves it up to the runtime to do that when it's necessary. And this can actually result in some problems if you try and catch exceptions in C. And this is from a library that I maintain called libsass Python, which is the Python bindings to the C++ libsass Sass compiler. And this is way back in 2015, raised by my good friend Kent, who showed that when you Control-C a build, you will get this C stack trace as a side effect of a segfault. This is debugging in GDP to show when the problem is. And the problem occurs inside this exception to Sass error, which is the error handling code that I wrote in libsass, and where the bug lives. And I played around with this a little bit, and interestingly, I couldn't reproduce this bug if I just raised keyboard interrupt in pure Python code, even though you'll notice that I'm using no parentheses here, so it's not actually exactly the same issue as what we're talking about today. But it turns out when you use raise from Python, at least in Python 2 way back when, it instantiates this object more eagerly than when it's raised from C. And when you Control-C on your keyboard, what actually happens is there's a signal handler in CPython, and that signal handler is what sets the keyboard interrupt exception, and then unravels the stack and makes that happen there. But yeah, I tried to reproduce this in a test, and I was having trouble with that. But then I eventually figured out what was going on and made a pull request for it. And so it turns out is the C API, which I don't know if this link still works. Yeah, it still works, cool. Even though this is the Python 2 docs. The C API states that the p-value and p-traceback, which are the exception value and the exception traceback, may be null depending on how it was raised. And my fix for this was to call this pi-error normalize exception CAPI, which will set the traceback and set the value if they're null at that point. To just like to make this actually work. And that fixed the bug, which was pretty cool. But anyway, hopefully hopefully this showed you something, and thank you all for watching, and again, thank you for sending in the question. And if you have other stuff you want me to explain, yeah, hit me up on Twitter, comment on the YouTube video, join me on my Twitch stream, etc. But yeah, thank you all for watching, and have a good one.